All right, good morning, good afternoon, good evening, guys. Trying something new here just to see how things will work out. Not sure how much time we'll have tomorrow to go over the test, and so wanted to make sure that you guys had a chance to look over some things and like, you know, make your corrections as needed. So just going to quickly walk you through this. Like I've said before, if you have a video, you can go back and look it over. But in number one, we've got the slope of 1/2 passes through the point 3,5. You can actually do this one in two different ways. If you graph the point 3,5 here, I've graphed that point right there. I've got hope you can see my cursor here. You know what might be better? Let me do this. If I download it, maybe I can actually use a cursor and it would be better to see. Let's see if that turns out. Yeah, I think that'll work a little bit better, and it looks nicer too. Okay, so if you notice here, I graphed 3,5, and if you do the slope of 1/2, you can do up 1 and over 2, place a point there, or you can go down 1, left 2, down 1, left 2, okay? And what you're going to notice here, if I zoom in, and I think some of you did this, which is fine, but doesn't always work, and you guys ran into trouble when you got to some of the other problems. If you look right here, if I'm going down 1 and over 2, then I must be going down 1/2 and over 1, down 1/2 and over 1. So this right here is 3.5, and that's what I have here, the slope of 1/2 with the y-intercept of 3.5. Now that won't always work, and I'll show you why in a little bit, but what you could have done is plug the y in for the y, the m in for the m, and the x in for the x, and just simplified. 1/2 of 3 is 1/2. If I subtract 1/2 from both sides, you get b, and then you can plug that in there, okay? So that was number one. Number two, if you didn't catch it, I'll go back and watch it. I've got the slope of 2/3 passes through -3, 3. Well, again, if I go ahead and graph -3, 1, 2, 3, and then 3, 1, 2, 3, I've got the point right there. Slope of 2/3 up 2 over 3, well, that puts me right at 5. So I know right away that the y-intercept is 5, okay? Now, you know, that's one way you could do it, but I'm going to encourage you to always go back and do it this way right here, because that way it won't always work. So if I plug in the y value of 3, if I plug in the x value of -3 with the slope of 2/3, some of you struggled with this right here, 2/3 times -3. One of the things that you could do, and let me go look at this, one of the things you could do, if I use my pen tool, is put this over 1. Now if I multiply this out, 2 times -3 gives me -6. Doing this on my laptop here is kind of tricky. And then 3 times 1 is just 3. Well, what is that going to be? What you're going to see here is -2. Okay. Some of you forgot the negative when you brought it down, so that's -2, and I want to add 2 to both sides, and that's how I end up with 5 there. So in the end, don't forget to put the whole equation together. 2/3 of x plus 5 is equal to y, and that is the equation of that line. Okay. All right, now if we go on to number 3. Number 3, some of you forgot to graph it out. Okay, it says graph all the lines there. So as I plot that point, -110, positive 235, that point's right up there. The vertical line would be that line right there. Okay. Now what's the equation of that line? Well, it never passes through the y-axis, so there is no y. It's just x equals 110. And every point on that line, the x value will be 110, -110, sorry. For number 4, if I look at number 4, first thing I'm going to do is find my slope. The change from 5, you got these 2 points. Actually, maybe the first thing you should do is graph it. And that's what, you know, down here we've got -3, positive 5, and we've got positive 1, 6. Okay, now if I connect those two, you've got your line. A lot of you came up to me and said, where is that exactly crossing, you know? I can't quite tell, and some of you put down 5.5, and that was major points off because it's not 5.5, okay? And so if I do the slope here, you can either count it up 1 over 1, 2, 3, 4, okay? And it's in a positive direction, both are positive. To rise 1 and to run 4 to the right, both are positive. So we have 1/4, or you could look at it from 5 to 6, we're going up 1. From -3 to positive 1, we're going up 4. Okay, so rise over run 1/4. Now from there, if I plug that into my equation, You got your y equals mx plus b, and I chose the first point here. So I plugged the 5 in for the y value, the -3 in for the x value, and I have my slope of 1/4. Same thing that I did on the last problem can hold true right here. Let me actually scroll down a bit. If you go ahead and place this over 1, it makes the multiplication a lot easier, a lot clearer, I think. You can see it better. 1 times -3 is -3, and then 4 times 1 is 4. So what you see right here, whoop, we have right down there, okay? And so from there, if I go ahead and add 3/4 to both sides of my equation to get b by itself, because it's negative over here, you get your 5 3/4. Now, you still want to finish up the equation by writing it out as an equation. So we have our slope of 1/4, y-intercept of 5 3/4, and that is the new equation, okay? All right, now moving on to the back side, these two were big point problems here, okay? I get frustrated because I have sophomores, juniors right now that cannot solve this type of problem. They struggle with it, and I'm hoping that you guys are getting this down. But if I want to get y by itself, I want to subtract 3x from both sides. Well, I've got that right there. So it's 7y equals -3x minus 14. Now from there, I want to divide both sides by 7 to get this y by itself. So if I divide both sides by 7, both sides, I said, not just one side or one part of a side, it's both sides. So some of you just divided this by 7, and you forgot to divide this by 7. Okay, make sure you do both of them. So I've got a little bit of a messy fraction there, 3/7, not a big deal, but it's -3/7. Some of you, when you divided the 14 by the 7, forgot that it was -14, and you put down +2 here. It's -2, okay? -14 divided by 7, -2, okay? Now, after that, it then says, I want a line parallel to this one, so now this one, okay, and has a y-intercept of 4. Well, if it's parallel, remember how we've talked that parallel lines have the same slope. So as I look right here, we've got the same slope as the previous equation up here, -3/7. And if it's got a y-intercept of 4, well, that's easy. I just plug it into the equation, and I've got that there, okay? So as I graph these out, the first one was at -2 with a slope of -3/7, so -3, +7, 1, 2, 3, 4, 5, 6, 7. There's my point. And the second equation was at +4, again with -3/7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Booyah. Okay? So, taking a look at the next one. All right, so when we look at number 6, first thing I want to do, well, first of all, we're looking for a line perpendicular to this one that goes through this point, right? So I need to know what the slope of this line is. So the slope is -3. The perpendicular slope, which I hope you have down by now, is the opposite reciprocal. So it's a +1/3, okay? Now as I plug that into this equation, my slope is 1/3, and my point is -2, that's my x value, and 5, my y value. Now I can go ahead and solve for the y-intercept here. Here's what I did. Again, if I put this over 1, you get a -2 over 3, -2/3. Now to get b by itself, we're going to go ahead and add 2/3 to both sides to get 5 2/3. So this equation right here that I'm showing you, you can't see it very well, right there, is the equation of this line right here, okay? So if I go ahead and put down, well, I think what I did, I put down the ordered pair of the point, -2, 5. So -2, +5. And then from there I did a +1/3 slope, up 1 and over 3. Okay, so that's that line there. The other line, I just went ahead and graphed it out. Y-intercept of 1 with a slope of 3. Is it -3? Yeah, -3. Okay. So I can do -3, +1, or +3, -1. Either way, you've got that line there. Okay. And you can tell, that looks like a right angle, doesn't it? Okay. So that's perpendicular. All right. This section, I'll be honest with you guys, I was a little frustrated that we didn't do a little bit better job on this. I I'm going to start with the one that has absolutely no correlation. So as you look at all of these, which one doesn't seem to have any directionality about it? It's number 10, okay? No directionality. They're all scattered, and scattered is, okay? It's just all scattered out, okay? Now I'm going to go to the opposite end of that. I've got a really strong negative correlation, okay? Almost in a straight line. Well, the only one of these that could possibly be would be this one right here, okay? Very strong negative correlation. Now the only fairly strong positive correlation, this one goes up and to the left, this one goes up and to the right, that would have to be this one. Positive, strong correlation. And then a moderate, getting stronger, okay, negative correlation would be this one. You can see it's going up and to the left, and they're getting closer to being close to each other, okay? All right, number 11, the scatter plot. You had to plot those points correctly, and you're just going to go ahead and estimate where this line is going to be, okay? Now, all of our equations are going to be possibly different for number 12, but for number 11, it is a positive correlation going up on the right. Fairly strong. Excuse me. Fairly strong. Looks like it's, you know, pretty close to 1 if I was to guess the R value. Okay. Now, how do I figure out the line of best fit? Well, once I've estimated it, I need to go ahead and figure out that line. Now, what I did was I think I took a point right here, 1055, so I guessed what that one was going to be. And I went out to 50 and guessed what that was going to be, 5095. Actually, I thought that this point was on my line. Some of you used just 2 points over here, but the point wasn't even on your line. You've got to be careful of that, because when the point's not on the line, that's not an accurate depiction for the equation line. Okay. Now, I went ahead and found the slope. The change from 55 to 95 would be 40. The change from 10 to 50 would be 40. Now, some of you had a little less than 1, some of you had a little more than 1, and as long as you calculated it out correctly, I was okay with that. Okay. From there, I took this first point with this slope, okay, and plugged it in, the y value, the x value, and the m. If you multiply those together and subtract 10, you get 45, so my equation was this right here, okay. Now, some of you tried guessing. Okay, and I took your slope that you had, and I plugged it all in, and I could tell that you did not work out the correct equation to figure out the y-intercept. Some of you thought that the y-intercept was 0. Well, if you look there, there's a little break in the graph, that little jagged line right there says there's a break in it. All of these are at a difference of 10, so 80, 70, 60, 50, 0. So some of you went, said 0. Now we're not going to drop off 50 that quickly. Okay, we're going to cross the y-axis, somewhere in the 40s would be my guess. Okay. Now from there, for number 13, predict what the score, what the percentile will be, what the percent you'll get if you study for 37 minutes. Well, if you look up here, a lot of you just estimated what you thought it to be at 37 minutes, which for the most part isn't wrong. I took probably 1 point off for you if you just estimated. But what I wanted to see, it says use the best fit equation. So you're going to use this equation to figure out this percentile, which means plugging in the 37 minutes for the x and solving for the y. Okay. All right, now for number 14, there weren't too many of you that got this wrong, which was good. But if I were to go ahead and throw something out, you can't use these, but if I were to use some equations here, let's say we were to use y, I'll just put y equals for all these before we get going. Using my laptop's not as easy as the board. So if I were to go ahead and say that line A and B had to be parallel, you're looking at something like this. If I was to go ahead and use a slope there, that's not working out so well. So y equals 1/2 x plus 2. Okay? So I come down here, I'm at positive 2, and I go up 1/2. Okay, I think most of you know how to graph those out, so we're good with that. Okay, that line right there. And that's a terrible line, so I'm going to erase it. Okay? So a parallel line would have to have the same slope and a different y-intercept. So I'll put -4. Okay, so I just go down to 4 negative, and then go up 1 over 2. Up 1 over 2. Okay, so you've got that line there. Now for the perpendicular, I'd have to look at these two slopes and ask myself, what's the perpendicular slope? Well, the perpendicular is the opposite reciprocal. So the opposite would be a negative, the reciprocal would be 2. So y equals 2x, let's say plus 1. Okay, it doesn't matter what the y-intercept is on this one. The key is that the y-intercept for the parallel lines is different. Okay, so if we do that, plus 1, and then a negative 2x, negative 2 over 1. Negative 2 over 1. Okay, and so what you're going to see as you draw those in, just rough sketching them there. Okay, now if yours looks that terrible, I'm probably going to count you off, but I'm just freehanded on my computer. So I hope that makes sense to you. I hope you learned a little bit more by doing this review. But guys, I'm telling you, some of you went to the chapter test and said, I'm confused, I don't know what's going on, after a half week of review. And that really perplexes me, and that really kind of scares me for what you're going to encounter next year, because geometry is a lot more difficult. Algebra is more difficult than that, Algebra 2, and you just, you got to be better students, okay? Especially when you go off to university someday, you're not going to get these extra opportunities. So I care about you. I want to see you succeed. I want to see you get your highest score possible, and that's why I'm giving you these extra chances to do that. But next year, I'm going to have too many students. I can't do that. So I'd like these corrections turned in as soon as possible. If you have any questions with the corrections, come and see me. Thank you for listening, and good night.